This lesson's going to be about graphing logs. So all those graph transformations that we have been doing with every other function, we're going to apply to log functions now. So I want to look at how you're going to develop your base function before we start shifting it around. Because depending on what the base of your log is, your base function will change just slightly. So if I'm going to be graphing my base function, what I need to do is pick numbers that I can plug in that will give me definite numbers out for my y. Okay, so what we're going to do is remember that the other representation of this is 3 to something. Okay, I want 3 to something, or 3 to my y's have to equal my x's. So when I'm plugging x's in, I want something that came out of a power of 3. For example, we can put 1, okay, if I want, well, we can put 1 in for x. Okay, because that means 3 to some power equals 1. Well, that power is going to be 0. Okay, because 3 to the 0 is 1. So that means if I put 1 in for x, I get out a 0. I can also put in a 3. So log base 3 of 3, of course, is 1, because 3 to the 1 is 3. Okay, so you almost could just pick your normal numbers on the right side over here for your y's, and then determine which x's will get you there. Okay, so the normal numbers I put in are like -2, -1, 0, 1, and 2. Okay, so let's look at doing it that way. Well, what's going to bring me to -2? So really, I'm taking 3 to the -2nd power, and that's going to give me 1 over 3 squared, which is 1/9. 3 to the -1 is now 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Okay, so if you want to switch it to this and pick your y's to get out your x's, you can do that also. Okay, that's kind of what I'm doing here. I'm picking the generic values that I always do, putting them in for my exponent to get out my value. Okay, and that value is really, so if I put in 1/9 in here, I would get out -2, and so on. So my base function is going to follow this. Notice that regardless of what my base is, this is always going to be true. I'm always going to cross at 1, 0. So this will be a point on every base log function. Okay, and the rest of these are going to change based on what your base is. So let's look at if we had a different base. So if I had log base 2 of x, okay, well then I could put these same y's in, but this time I'm going to get out 2 to the -2, which is 1/4. Okay, 2 to the -1 is 1/2. This is still going to be 1. 2 to the 1 is 2. 2 to the 2 is 4. Okay, and these would be my x values for this function. Okay, but I'm still going to graph this one. So if I put in 1/9, so I'm going to go over 1/9, which is just barely over. I'm getting out -2. Okay, if I go over 1/3, which is a little bit more, I'm getting out -1. I've got that point. If I go over 3, I'm up at 1. If I go over 9, I'm up at 2. Okay, so this is going to be our asymptote. Because no, I'm never going to get any negative numbers. I can't put negative numbers in for my x. Because no power, if I take 3 to some power, it's never going to come out negative. It's either going to be a fraction, okay, or some kind of whole number, or not whole, but some kind of positive number. So this is an asymptote, and we're going to follow that, okay? Because if I were to put in like 1 over 27, I would get out 3, -3. Okay, if I put in 1 over 81, I'd get out -4. Okay, so the smaller I get toward, or the closer I get towards 0, the lower I'm going to go. So this is following this asymptote, and then it comes up, and it just real slowly rises, because I'm not going to cross 4 until I'm way out at 81. Okay, because log base 3 of 81 would be 4, so I'd have to go all the way to over 81 before I'd be up at 4. I'd have to go all the way to 27 before I'd hit 3. Okay, so it's increasing very slowly as we go that way. So that's my base function. That's my base function. I'm going to graph this guy now. So all our rules for graph transformations are still going to be the same. Okay, so the first thing you're going to have to do is factor this. Okay, you're going to factor the inside part, so you have -2. That turns this into x, and that turns this into a -2. And then -3. So we could use this as my start point. Okay, if you want to use that as your start point. Or we could use 0, 0 as your start point. Okay, it's up to you. So we'll do 0, 0 just because that's what we're more used to. And plus, then we'll be able to see where our new asymptote is. So my start point has been moved to the right 2 spots. So that means my asymptote is now going to be over here at 2. So this is going to be an asymptote. It's also the line I'm going to approach. Okay. My start point's been moved down 3 spots. 1, 2, 3. Okay, so this would be like my 0, 0 right there. Now, it used to be that I went over 1 and up none. But now, instead of going over 1, I'm going to go the reciprocal of this. So I'm actually going to go left because of the negative, and I'm going to go left a half. So left 1/2 puts me here. I don't go up at all. If I went over a third, that put me at -1. Now, instead of going over a third, I'm going to go over half as much. So I'm going to go over a 1/6. And instead of going down 1, I'm going up, or down 2. Now let's look at this one. I used to go over 3 up 1. But now I'm going to go over half as much, so that's 1/2. Instead of going up 1, I'm going up twice that much. Okay? Because remember, this is our y movement multiplier. This is our x movement divider. We'll do one more. So instead of going over 9, I'm going left half as much, so 1, 2, 3, 4.5. Instead of going up 2, I'm going up twice as much. 1, 2, 3, 1, 2, 3, 4. And now I've got a general picture of what my graph is doing. So this would be my transformed log graph. Okay, so all the same stuff from our graph transformations. So I'll show you one more. Okay, so our base has changed. Okay, so it might help if we plot some. So we can do our base y and then our real y. So my base function will go here, and then we'll make another column for our actual function. So this is our transformed. So base function, remember those are going to be our normal numbers. If I take 2 to the -2, I get 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. Okay, so I'm going to factor this. So I'm taking a 1/2 out. That's what 0.5 is. So when I divide a 1/2 out, it's the same as multiplying both these by 2. So this can turn into 6. Okay, so instead of going over a 1/4 and down 2, I'm going to go over twice as much. So I guess let's put our x and y in here. So instead of going over a fourth, I'm going to divide that by a half, which is the same as multiplying by 2. So 1/4 times 2 is 1/2. I'm going to go over a half. And I'm going to go, I don't have a multiplier, so I'm still going the same thing, down 2. This is going to turn to 1. This stays the same. This turns to 2. This stays the same. This turns to 4. This stays the same. This turns to 8. This stays the same. Okay, this is my movement. I just need to find my start point. So my start point is going to be to the right 6. 1, 2, 3, 4, 5, 6. So that's my vertical asymptote. So here, I'm actually going to change my graph a little bit so we can get all this on there. Okay, so I moved my x-axis, or my y-axis over a little bit so we have a little more room. So I'm going to go right 6, 1, 2, 3, 4, 5, 6. That is my vertical asymptote. Up to 1, 2. So this is my new 0, 0. Okay, figuratively speaking, this is my new start point. And this is my movement from there. Over a half, down 2. Over 1, down 1. Over 2, down none. Over 4, up 1. Over 8, up 2. This is my transformed function. Okay? And that's how we're going to graph our logarithms.